For this lesson, let's take a look at solving some more linear equations. I've put the 4 steps that I want you to become familiar with for solving equations at the top of your page. And I'd like for you to pay attention to which step you start on or which steps you use to solve the equations as we go through them. The first one, I'm going to simplify on both sides of the equation. I'm starting with step number 1. On the left, I have nothing to do, so I'm just going to write down negative 4y plus 10. On the right, I have to distribute multiplication. I'll have negative 6y, and then I'll multiply negative 2 times 1 and have minus 2. Now I want to get my variables together. This is step number 2, get the variables to the same side. And I'm going to recognize that negative 6y is smaller than negative 4y. So I'll add 6y to both sides. These will cancel. Negative 2 is all that's left on the right. And on the left, I will have 2y plus 10. Now I want to do step 3, get rid of any number that's added or subtracted on the variable side. In other words, isolate the variable term. So I'm going to subtract 10 to get rid of this positive 10. And I have 2y, the 10s are going to cancel, is equal to a negative 12. The final step, step 4, divide by the coefficient of the variable. When I divide, these become 1s. Y is now equal to negative 12 divided by 2, or negative 6. Example 2, we don't have to simplify on either side, so we can skip that step. We do need to get the variables to the same side, so we start at step 2. I'm going to start with my smaller variable, 9x, and I'll subtract it from both sides. I end up with 15 minus 9x, which is 6x, minus 8, and that's going to equal 10. The 9x minus 9x will cancel, turn into 0. Now I want to isolate the variable term. I've got to get rid of this negative 8, so I'm going to add 8. This is step number 3. I'll have 6x on the left and 18 on the right. The final step, step 4, divide by the coefficient of the variable. My 6's will cancel. X will now equal 18 divided by 6, or 3. Example number 3, we do have to distribute multiplication over on the left-hand side. So I'm going to say 8. I'm going to say negative 2 times a is a negative 2a. And negative 2 times 1 is negative 2. Don't forget, the negative, the sign, stays with the term that it's in front of. So if you're distributing that 2, you have to distribute a negative 2. And that's equal to 9 plus a. Nothing to be done on the right-hand side. Now, I'm going to get my a's together. So I'm going to go ahead and subtract a out. Now look, I realize that I'm making a sort of mistake here because 1a is what I have on the right and I have a negative 2a on the left. The smaller one is the negative 2a. But I want to show you what happens if you pick the wrong term to work with. It still works, you just have an extra step at the end. On my right-hand side now, I'm going to have 9 is all that's left. And on the left, I'm going to have 8. And this is going to be 1a, of course, so it's minus 3a minus 2. Now, I'm going to combine these terms over here. Should have done that as my first step. I should have combined my 8 and my negative 2. Well, so that makes 6 minus 3a. But as you can see, it didn't hurt for me to do it out of order either. And now I want to get my a term isolated, so I have to get rid of the 6 that's in front of it. It is a positive 6, so I'm going to have to subtract it. That cancels the 6. I have a negative 3a left. Don't forget the sign that's in front of it stays with it. And what's left is negative 3 is equal to 3. We divide by the coefficient. Here's the part that's different. We divide by the negative 3. And that cancels. Those become a positive 1. And a, I'll have to write it over here, is now equal to 3 divided by negative 3, or negative 1. For example number 4, we're going to start off with get the variables to the same side. Step 2, working with this negative 2y, we'll add 2y to both sides. And we end up with negative 10 equals 7y plus 18. Now I want to isolate my variable term. Step 3, I'll subtract 18 to get rid of this positive 18. And I have 7y is equal to a negative 28. divide by the coefficient of the y term, of the variable, and this means that y is going to be equal to negative 28 divided by 7, which is a negative 4. Example 5 and 6 are a little bit more difficult. They require us to do something called clearing fractions. You never want to work equations that have fractions. Whenever you have a fraction, any fraction, one fraction, two fractions, or all fractions in an equation, and it has to be an equation, it has an equal sign, you can get rid of these fractions, turn them into whole numbers, by multiplying every term in the equation by the least common denominator. Well, in example 5, the denominators for our three fractions are all 3. We want to get rid of those 3's. We want to turn these terms into whole numbers. So we're going to multiply by the multiplicative inverse, which is going to be 3 over 1 here is what I'm going to multiply by. Let's multiply by, not the inverse exactly, but the inverse of a 1/3. I'm going to multiply everything times the common denominator. And I'm putting it over the number 1 because I'm multiplying fractions. So the first term that I multiply, 3 over 1 times 2 over 3, when I cross-reduce before I multiply, these 3's turn into 1's. I really just multiply 1 times 2x. I have 2x over 1, which is just 2x. It turned into a whole number. So the next term, there's a plus between them. I'm going to also reduce the 3's, cross-reduce, and I'll end up multiplying 4 times 1, which gives me the whole number 4, because it's over the denominator of 1 again. There's my equal sign. I have to keep track of it. I've written all over it. And now I'm going to multiply, once again, cross-reduce these 3's. Negative 2 times 1 makes negative 2. This is a much easier equation for me to solve. If I do multiply every term by the common denominator and I don't end up with all whole numbers, I've done something wrong. I might as well scratch the problem out and start all over. But you should, when you do this, end up everything is whole numbers. All you have to do is multiply each term by the common denominator. In essence, you're doing the same thing to both sides of the equation, which is okay. Now, I want to get rid of this 4 that's added to my variable term, which is step number 2. And I have 2x equal to negative 6. And step number 4 is the last part. I'm sorry, that was step 3. Step 4 is the last part. Divide by a 2. And x is equal to negative 6 divided by 2, which is negative 3. Example number 6 requires us to recognize that 2 times x plus 1 over 4 is really just one fraction. If we want to clear that fraction, we multiply by the denominator. The denominator is 4. So what happens when I multiply it times 4 over 1? And I multiply the other two terms in my equation, 3x times 4. It's not a fraction, so I don't have to write it over 1, do I? And I multiply the negative 2 times 4. Well, in the first term, my 4 over 1 times is going to cancel with the 4 in the other denominator. Those would turn into 1's. What do I have left? I have 2 times x plus 1. And that's going to be equal to 3x times 4, which is 12x. And that minus 2 times 4, which is 8. Now, I have an equation that I'm used to. I distribute multiplication. 2x plus 2 equals 12x minus 8. I get my variables together, subtracting the smaller one or working with the smaller one. I have 2 is equal to 10x minus 8. I isolate the variable term by getting rid of this negative 8. I'll add 8 to do that. I have 10 is equal to 10x. And then finally I divide by the coefficient of the variable. And I have x equals 1. Example 7, a little simpler. Let's distribute multiplication. 4 times 3x is 12x. 4 times 2 is 8. And that's equal to 12x plus 8. Wait a second. These look identical to me. 12x plus 8 equals 12x plus 8. At this point, we've hit a very special equation. Let's just say we didn't notice that, which we would subtract one of these 12x's, which means we're going to subtract 12x from both sides, right? What happens? Well, the x's are going to go away. What's left? 8 equals 8. That is a true statement. 8 is equal to 8. When this happens to you in an equation, you can say that the solution is all real numbers. Any number that is a real number that we plug in for x will work for this equation. Let's take a look at number 8 now. We've got 3x minus 7, which we can't simplify. And on the right, we say 3 times x, which is 3x. And we say 3 times 1, which is 3. Now I'm going to get my variables together. I'm going to subtract out a 3x from one side or from both sides. What happens? The 3x's are once again going to cancel. I have no x's. Instead, I have negative 7 equals 3. Well, this is not a true statement. This one's false. Negative 7 will never equal 3. Therefore, there is no number that we can plug in for x that will work. So for this particular equation, we say that there is no solution. Two special cases, number 7 and number 8. If you come up with a true mathematical statement, 8 equals 8, all real numbers, anything will work. If you come up with a false mathematical statement, like negative 7 equals 3, you have no solution to the equation.